Hey, hi everyone. Welcome back to Court of Management. So we are again with the Spring Boot playlist, Spring Boot discussion series. So here, building, right? Like building a simple API is easy, but when you will need to build a massive admin dashboard or any large enterprise application where the user can filter by name, their city, their date, status, all optionally. So just think, your simple like find by ID will not work. So if you try to write that using standard JPQL, the Java persistence query language, what we have discussed in the last lecture, then you will end up with a messy, unreadable queries, right? So today we are mastering advanced data querying in Spring Boot. So we are gonna look at when to break the rules and write pure SQL using native queries. Then we will look at the type safe object oriented criteria API. And finally, I am gonna show you the absolute cleanest enterprise standard way to write dynamic search filters, the Spring Data Specification API, right? So just level up your backend architecture. So at first, we will discuss about what is native query. So a native query means writing pure raw SQL instead JPA. So what we are doing here, we are writing pure raw SQL directly inside JPA. So you literally just add native query equals to true to your query annotation. Okay. So the example I have here, I have attached the query annotation there in value equals. You will write the query like select star from user details where username is something and native query equals to true. So what are the key characteristics of it? So direct DB interaction, no JPA caching, no lazy loading, no entity lifecycle management, and if DB changes, query breaks. So what does it mean? So that is a catch. When you use the native queries, you completely bypass the JPA. So there is no first level cache, no lazy loading, no entity lifecycle management. Plus, if you switch your database from MySQL to PostgreSQL, your queries might break. So when should an architect use them? So you use them for database specific features like PostgreSQL, JSONB operations, window functions, or massive bulk updates where performance is the only thing matters. Okay. So in that cases, you can use the native query. So if you do select star, like see here, like full entity versus partial fields. So first case is select star, like you are selecting all everything, and case two is selecting specific columns, means some specific things you need from the database, all things you don't need. So if you do the select star, then JPA maps it to the entity easily. But if you only do select username, phone, then JPA panics. So you can solve these the enterprise way using SQL result set mapping. That's the enterprise way to map it directly to the DTO, or the first way by returning list of array of objects and manually mapping it in your Java stream. I highly recommend the manual mapping for most microservices because it is fast and simple and flexible. So when you will do the map. So here we have discussed like full entity versus partial fields, but we came to know when we will do the partial fields, selecting the partial fields or specific columns, then JPA panics, it will be slow, something like that. To solve this, to do the mapping of partial results, there are two ways. Method one is SQL result set mapping annotation, which is the enterprise way, and another one is manual mapping. So most used this manual mapping in your microservices, which is simple, fast, and flexible. Next is dynamic native query. When filters are optional, okay, like where one equals to one and name, city, something, then build using StringBuilder. So in that cases, you can use the dynamic native query. So where it is being used, like admin panels, search APIs, reports, okay. Pagination and sorting in native SQL using limit, offset, order by column DSC handled manually in SQL. Unlike JPQL, JPA does nothing here, okay. As just think in that way, like whenever you will write the native query, then the JPA component or JPA thing is totally gone. You are bypassing the JPA. Now our next segment is criteria API, the safe dynamic queries. So native queries are messy and hard code your database type. So what if we want to write dynamic queries in pure Java? So they are type safe and database independent. So that's why criteria API came into picture. So that is not portable, DB dependent, and criteria API are type safe, DB independent. Like native SQL is DB dependent, criteria API is DB independent and object oriented. So that's why we use mainly criteria API. So there are some core components of this criteria API. So first one is criteria builder. So what does it do? The factory used to create the query and conditions like equal, like. So to create the queries, mainly criteria builder helps. Next is criteria query. So it defines the structure of the query, the select part. Then the root. So it defines the from clause. Then predicate. That is your actual where condition. And typed queries executes. So criteria builder, criteria query, root, predicate. These are main core components. So you can use select to return full entities or multi-select for the partial fields. But let me be honest with you, the criteria API has way too much boilerplate. Writing a simple dynamic search takes 50 lines of codes. It duplicates the predicate logic and becomes a nightmare to maintain. So, like for criteria operators also you can see, like for comparison we have like cp dot equal cp dot greater, like gt is greater dot lt is less than, gt is greater than, lt is less than. Some logical operators we have like cb dot and, cb dot or, cb dot not. Then string, let me do in that way. So that is logical part, then the string part. Okay, so for string we have cb dot like, cb dot not like, and for collection we have cb dot in and cb dot not in. Okay, so we can do this much operators with the help of criteria API. But I have told you the boilerplate code for this criteria API is used, so that is hard to maintain. So there is a better way. So we have the specification API. That is the cleanest approach. Okay. So what were the problems? Too much boilerplate code, duplicate predicate logic, hard to maintain. So specification API is the solution. What was the problems for criteria API? Again, I am telling that is there is too much boilerplate code. It has some duplicate predicate logic and hard to maintain. Okay. So to solve the problems of the criteria API, we have the specification API as a solution. So Spring Boot saw how ugly the criteria API was and built a beautiful wrapper around it. That is basically the specification API. Okay, like Spring abstraction on criteria. So you only write two predicate. Okay, so instead of writing all the builder and query boilerplate, you only need to write the two predicate method, and Spring handles the rest. Here you can see one public class user specifications. Here we have the specification has name method. There we are passing name and we are using cb.equal and all. Then specifications, this has cb.equal, we are using ct with that. Then after checking that. So Spring handles the builder query executions. Okay. So now your repository just extends the JPA specification executor. So look at how beautiful and readable your service layer becomes when you want to combine optional filters. So what are the ready-made methods here, like find all, find one, exists, find all, like here the specification and pageable you can pass. So it is reusable, clean and testable. So see, like in spec, like specification dot where user specifications we have made here, and then we are using like user specification dot has name John and has city. With these two, we are filtering. Then we are returning through find all. Okay, like for the users is user repository dot find all. So combining specifications is easy with this specification API, spec1 and spec2, spec1 dot or spec2 specification dot not. Okay, so perfect for search filters, dynamic APIs, admin dashboards. Okay, so comparison table. So here we have made one comparison table between the native query criteria API and specification API. So DB independent. So no, native query is DB dependent. It is not independent. Criteria and specification API both are DB independent. Type safety, native query is not type safe. Criteria and specification APIs are type safe. Boilerplate, native query has low boilerplate. Criteria has high. Specification has too low boilerplate code. Maintainability is low for native query. Criteria is medium. Specification high maintainability. Performance, native query performance is high. Criteria medium type. Specification also medium type. Best for reports, we can use the native query. For dynamic queries, we can use the criteria API, and real projects, we can use the specification API. So real industry rules, these are the like what architects follow mainly. So like always avoid native query, like native SQL, unless absolutely necessary for DB specific features or complex reports. Next is use specification for search APIs. Use JPQL for joins. Whenever search APIs is there, you can use specification. You use JPQL for joins. Use the native for reports. Always return DTO. Never expose object array. Combine specification with pageable. What I have shown you here, you can here see, like find all. Not only specification, you can also combine with the pageable. Okay. So never hardcode SQL in controllers. And few points also I am telling, just remember, like native queries, bypass the JPA lifecycle and cache. Okay. So like the your first level cache, it also bypass. Criteria API is type safe, but verbose. Specification API is the abstraction over criteria. Okay. Specification API is the abstraction over criteria. Partial native results require manual mapping. That also I have discussed here. There are two types of things, right? I have told you. One, like for partial fields, like for partial results, one is SQL result set mapping. You can use annotation like SQL result set mapping annotation, which is the enterprise way. Another is manual mapping. Okay. So partial native results require manual mapping, and specification solves the code duplications, as criteria API has many problems like too much boilerplate code, then duplication of the predicate logic, and hard to maintain. Okay. So I hope these things are helpful for your upcoming interviews. If you need any more things, then you can comment below. I will definitely discuss those topics. Thank you everyone. Don't forget to like, share, and subscribe.